Hey guys, it's Conversion Diverge with another video. Currently today it's July 22nd, and as most of you will know, 22/7 is a famous approximation for pi by Archimedes. So I thought it would be fun for today, for the Pi Approximation Day, we could actually go ahead and try out the drawing out the 96-sided polygon which Archimedes used to approximate pi, and we can actually try to approximate pi ourselves by using that 96-sided regular polygon. And without further ado, let's get right into it. So basically, to start off, we need the unit length, which we'll set as 1 centimeter, approximately 1 centimeter. Then basically what I'm going to try to do is draw out the 45-degree triangle and the 60-degree triangle, right triangles, which should just be like the 1:2 to √3 ratio triangle and 1:1 to √2 ratio triangle. And since that we will have 45 degrees and 60 degrees, then I'll be able to combine those two triangles together to deduct those two angles, deduct 45 from 60, it will get 15 degrees. And since 96-sided polygon is basically 360 divided by 96, it would be 15 divided by 4. So after we get the 15-degree triangle, 15-degree angle, we can just divide that by 2 times, and we'll have the angle necessary to draw the 96-sided polygon. Okay, my camera ran out of battery again, but okay, so basically you didn't miss out too much. I just finished drawing out the sides on the polygon. It turned out to be 94 and not 96, and that's pretty close considering how for the 120-sided polygon video, we instead got 84 I think it was, or something like that. So this is still pretty accurate. You can tell towards the end I was trying to fit it in, but basically it had left a little gap. So it's 94 point something sided polygon. So now that we have the polygon, we can attempt to approximate the value of pi. Okay, let's ignore that scratch over there from the previous shot I took. So anyways, now that we have the 94-sided polygon, we can do the approximation of pi, which isn't exactly what Archimedes did, but I thought it would be more fun to do it this way, because then we get to draw this pointless polygon. So we've got the formula: angle in radians times radius of the circle equals arc length. So here we want 2 pi, which is full rotation. Radius is about 9.3 centimeters, and then the arc length would be, the starting one is about 0.7 times, I guess, 94, since we didn't exactly get 96. So let's do that. Let's say this is theta, and let's see what we get. So we get, that's the previous one, 0.7 times 94, and we divide it by 9.3. We get a stupid value. Yeah, basically, what was that? 7.07. Pi equals, alright, I got 2 pi equals 7.0 something. So divide that by 2 would be, you got 3.54. Basically, if we round that up to 3 significant digits. Not exactly accurate, way off from pi, and definitely way off from 22/7 as well. So this again wouldn't be, this is method 2, and this wouldn't exactly be Archimedes' method either, but hey, we can just take the advantage of more modern math compared to his time. So basically, let's do a quick scratch drawing here. This would be the basic version of this, like a simplified version of that drawing. Got it here. This is 15 divided by 4 degrees, and this is 9.3 centimeters. And basically, we can calculate the length of this one side using cosine rule. 9.3 squared times 2 divided by cosine squared, cosine 15/4 in degrees. All of those to get the length of one side, which we did 0.6089. I think we got, when we did the polygon thing, we got 0.7 instead. Pretty close, but the margin of error, I guess, well, I mean, it became really inaccurate when we went to larger scale, like multiplying by 96 or 94. Since we are doing the ideal version right now, I multiplied that by 96 to get this value, which is the rough approximate of the circumference of the circle. You divide that by the radius, we get 2 pi, which is supposed to be this value. Divide by 2, and we get this value, pi. Now let's see what 22/7 is. Yeah, still a little bit off, but hey, at least the ideal version is way closer to pi than my actual calculated version, which was, what was it? 3.54. maybe that should be the real value of pi from now on. But anyways, this was just my take on Pi Approximation 22/7. I always use well, not always, but like when it was first introduced to us in like about middle school, I think, or first year of high school, I just took it for granted. I'm glad that I finally had the chance to do more research and actually try out the drawing itself out. Now that, well, I'm having trouble with all this modern equipment to even get a close value, and the fact that Archimedes did it all by hand and like drawing with a stick in the sand, I guess that's just how great he is and how really detailed and accurate he was when he did the approximation like thousands of years ago. So thank you everyone for watching. This was just my little activity for Pi Approximation Day. I have roughly about 2 hours to edit this video and upload it before July 22nd is over. So have a good one, everyone.